All right, today we're doing some more practice graphing log functions. In my first example, log base 2 of x plus 4 minus 2. Step 1 is to translate the graph. So the plus 4 gives me a left 4 and the minus 2 gives me a down 2. So immediately I'm going to come over here to my graph and put these in here. Left 4, down 2. Now if you go in your notes, you'll see a printed out, or you can print out these notes and copy along. So I took care of that plus 4 minus 2, and I'm not going to deal with that anymore. I'm going to take that out of the equation. So log base 2 of x equals y. And the easiest way to graph this log function is to rewrite this in exponential form. So it'd be 2 to the y equals x. And then I'm going to make a table of values, but instead of putting them in for x, I'm going to put the numbers in for y. So -2, -1, 0, 1, and 2. So replace the y with these numbers. 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4. These two are reciprocals. These two are reciprocals, so this is 1/2, this is 1/4. And I can graph these points starting at my new origin. So 1/4 of a unit to the right, I go down 2. 1/2 of a unit to the right, I go down 1. 1 unit to the right, I go down 0. 2 units to the right, I go up 1. 4 units to the right, we go up 2. So 1, 2, 3, 4, up 2. And this graph looks like this. And we have a vertical asymptote at x equals -4. The domain of the function, again the domain is your x, your left to right. It doesn't start until x reaches -4, but it can't equal -4. And it goes on forever to the right. The range is from your y values from bottom to the top, and it goes down forever, and it goes up forever. So there's the graph of example 1. Example 2, just a different base. Step 1, again, put in your translation. This one is left 5, up 3. So right away I'm going to put that in my graph, left 5, which actually gives me my vertical asymptote. Because logs have a vertical asymptote, exponentials have a horizontal, because these are inverses of each other. All right, so I don't need to deal with the plus 5 or the plus 3 anymore, so I'm going to rewrite this log base 3 of x, put the y over here on the other side, then rewrite it in exponential form, so around the world. It would be 3 to the power of y equals x. And when I make my table of values, I put in values of y, not x. Much easier to do that. So 3 to the 0 is 1, 3 to the first is 3, 3 to the second is 9. Again, these are reciprocals, so this is 1/3. These are reciprocals, so this is 1/9. And I just come over here and graph, starting at my new origin. So 1/9 of a unit to the right, down 2. 1/3 of a unit, down 1. 1 unit to the right, up 0. 3 units to the right, up 1. And then 9 units, I go up 2. So log graphs, very, very similar, the same shape. They have a vertical asymptote, and that vertical asymptote is your translation left to right. So in this case, we went 5 units to the left. The domain, well, it starts at that vertical asymptote. Goes on forever. And one good thing about these, the range is always the same. -infinity to +infinity. Example number 3. This problem has no base. So remember from a previous lesson, if it has no base, it's called a common log and the base is 10. But again, I'm still going to put in these translations. So left 4, down 3. Put that in right away, left 4, down 3. The left 4 gives me my vertical asymptote. Down 3, that's not a horizontal asymptote. The graph can cross through that, and it does. So take the +3 and the +4 and -3 out of the problem. It would be log base 10. You can write it if you want, you don't need to. Equals y, so go around the world. Now, there is something about this one I'll explain in a second. You don't have to do this, but I'm going to do it anyway just for practice. And again, I make my table of values. And I'm going to stick with the same values of y every single time. 10 to the 0 power is 1, 10 to the first is 10, 10 to the second is 100. That's not going to fit, but that's okay. And then the reciprocals. And I just graph these. And again, it's very, very, very similar to all the other ones. These points are always really close. But now I'm going to go 10 units to the right. And I go up 1. So right there. Now the other one doesn't fit, but all I got to do is draw the arrow towards that. It goes up, but it goes up slowly. Now the reason why I said you don't have to make the table when it's base 10 is because I can type this in my calculator. Calculator does base 10. I put in log of 8, it'll give me a value. Only because it's base 10. Well, there you go. Vertical asymptote again always comes from the shift left or right, so in this case it's x equals -4. Domain starts at that vertical asymptote and goes on forever to the right. The range always the same. That doesn't change. All right, last one. So this one is a shift right 2, which again gives me my vertical asymptote. In this case will be x equals 2. We'll write that down in a minute. So right 2, up 4. And again, all logs basically look the same unless there's some kind of flip or vertical or horizontal flip or stretch or compression. We're not doing the stretches or compressions. Right, so now take out the -2 and the +4 log base 3 of x equals y. Go around the world, it'd be 3 to the y equals x. These are the same exact values I used before on another problem. It doesn't hurt to practice solving these. See if you can come up with the values. 3 to the 0 is 1, 3 to the first is 3, 3 to the second is 9, then the reciprocals. So it's the same shape as problem number 2, just in a different spot. 1/9 -2, 1/3 -1, 1 0, 3 1, and it doesn't look like the 9 2 is going to fit. That's all right. Just draw towards that point, and that's perfect. My vertical asymptote x equals 2. My domain, that's where the graph starts at 2. It doesn't equal 2. That's why we have parentheses. And the range always the same. All right. Those of you who finished watching this whole video are in luck, because this is actually the homework from the night before. Thank you.